Hello friends, myself Mr. Kale Prasad Anil, lecturer at Mula Education Society's Mula Rural Institute of Pharmacy, So9. Today we will going to discuss antioxidants. First of all, content of this chapter are introduction, then we have to study about sulfur dioxide and sulfates. In that we have to study sulfur dioxide, sodium bisulfite, sodium metabisulfite. Then we have to study hypophosphorus acid and sodium thiosulfate. And lastly, we have to study about sodium nitrate and nitrogen. First of all, we have to start with the compound sulfur dioxide. So usually sulfur dioxide is colorless, non-flammable gas having a pungent and suffocating odor. It contains not less than 97% by volume of SO2. It is about 2.25 times as heavy as air. The gas is easily liquefied by cooling it with freezing mixture under pressure. It is soluble in water. 1 volume of water dissolves 40 volume of the gas at 20 degrees Celsius and at standard pressure, that is 760 mm, to form a solution of sulfurous acid. The reaction is as SA2 plus H2O, which gives H2SO3. Usually sulfurous acid ionizes in two stages. First one, H2SO3 ionizes as a H plus HSO3 minus. And second stage, HSO3 minus ionizes as H plus SO3 minus. Thus, the solution of SO2 in water is acidic. Then next one, uses of sulfur dioxide. Sulfur dioxide is used as an antioxidant. It acts either by reducing the oxidized form back to the original compound or by reacting with oxygen before the oxidizable compounds do. It is used in injectable preparations in the range of 0.01 to 1%. 0.1% is most common. It is used in industries for bleaching wood pulp, wool, silk, as well as in sugar industry to bleach and refine the syrup. It is employed as a gaseous fumigant for grains and for arresting fermentation. Sulfur dioxide has antibacterial and antifungal properties and is used as preservative in food, dried fruits and fruit juices. Then incompatibility. Sulfur dioxide has or sulfur dioxide is incompatible with oxidizing agents and thiamine. Many aromatic anions, example phenolates, inhibit their antioxidant action. Alkyl halides and compounds with alkene links react to give sulfuric acid derivative. The next compound, sodium bisulfite. Usually we call it as sodium hydrogen sulfide, sodium acid sulfide. Molecular formula is sodium bisulfide and molecular weight 104.6. Then first of all we have to see about the characteristics of sodium bisulfide. Official sodium bisulfite is a mixture of sodium bisulfite and sodium metabisulfite in varying proportions. It should yield not less than 58.5% and not more than 67.4% SO2. It is white or yellowish white crystalline or granular powder with the odor of sulfur dioxide. It is unstable in air, giving off SO2. It is readily soluble in water. Metabisulfite in it is converted to the bisulfite in aqueous solution. Reaction is as follow: Na2 H2O5 plus H2O, which gives twice NaHSO3. The next compound, sodium metabisulfite. Usually we called it as a sodium pyrosulfite, disodium pyrosulfite, and molecular formula is Na2H2O5 and molecular weight is 190. It contains not less than 95% of Na2H2O5 and not less than 64% of SO2. It contains small amount of sodium sulfite and sodium sulfate. Commercial sodium bisulfite is the metabisulfite. When bisulfite is specified, metabisulfite can be used as it is converted to bisulfite when dissolved in water. Reaction is as Na2H2O5 plus H2O, which gives twice NaHSO3. It is white to yellowish crystalline powder with sulfurous odor and acid saline taste. On exposure to air and moisture, it is slowly oxidized to sulfate with disintegration of the crystal. It is soluble in water, alcohol, and glycerol. The next one, uses. Sodium bisulfite and sodium metabisulfite are reducing agent, are used as antioxidant and preservative in pharmaceutical preparations like penicillin, suspensions, ascorbic acid injection, and preparation of steroids. Sodium metabisulfite is used to stabilize the solution or injection of drugs that contain phenol or catechol nucleus such as adrenaline. It is often used in concentration of 0.1%, but concentration in the range of 0.01% to 1% have been used. Sodium metabisulfite is used as a preservative in acid solutions and syrup. Its antimicrobial activity is due to the presence of sulfur dioxide and sulfurous acid liberated by reaction with acid. It is effective against most bacteria, fungi, and yeast at acid pH. This compound finds use in the food industry for preservation of dried fruits and fruit juices because of their antimicrobial preservation action. Sodium metabisulfite is used as a reducing agent in photography. As an antioxidant, sodium metabisulfite has certain disadvantages. It decomposes in air, especially on heating, so an appreciable amount may be lost during sterilization. Then storage. It is stored at temperature not exceeding 40 degrees Celsius in well-filled airtight container, protect from light. Then incompatibility. It is incompatible with oxidizing agent and thiamine, sodium metabisulfite inactivate chloramphenicol. Dyes get decolorized with bisulfite and metabisulfite. Aromatic anions like phenolates inhibit their antioxidant action. The next one, hypophosphorus acid and thiosulfates. These are mainly used for prevention of oxidation of iodides and ferric compounds. They act by reducing the oxidized product back to its original reduced state. We will see first compound, hypophosphorus acid. Molecular formula is H3PO2 and molecular weight is 66. Hypophosphorus acid is colorless or slightly yellow, odorless, deliquescent crystalline salt of an oily liquid. It contains not less than 30% and not more than 32% weight by weight of H3PO2. Dilute hypophosphorus acid contains 10% weight by weight of H3PO2. It contains only one ionizable hydrogen which is bonded to the oxygen atom. So it is monobasic or monoprotic acid. The oxidant state of phosphorus in it is +1, making it a very powerful reducing agent. It reacts with molecular iodine and reduces it to the iodide ion like H3PO2 plus twice I2 plus twice H2O, which gives 4Hi plus H3PO4. Then uses. Hypophosphorus acid and its salt are used as an antioxidant in hydriodic acid syrup, and ferrous iodide syrup in the concentration range 0.5 to 1%. Dilute hypophosphorus acid has been included in the preparation of ferrous salt to retard the oxidation. Storage. It is stored in airtight container. Incompatibility. Hypophosphorus acid is incompatible with oxidizing agents such as nitrate, chlorates and permanganates. The next one compound sodium thiosulfate. Molecular formula is Na2S2O3 5H2O and molecular weight is 248.2. Characteristics. It occurs as colorless crystal or as a coarse crystalline powder with saline taste. It is slightly hygroscopic in moist air and effloresces in dry air and warm air. It is soluble in water and practically insoluble in alcohol. Its solution is neutral or slightly alkaline in photographic field. It is known as hypo. Its aqueous solution decomposes slowly in cold but rapidly when heated as 4Na2S2O3, which gives thrice Na2SO4 plus Na2S5. It is nothing but the polysulfide. And then Na2S5 gives Na2S plus 4S. Then uses. The use of sodium thiosulfate as an antioxidant is usually limited to solutions containing iodides. The main medicinal use of sodium thiosulfate is an antidote in cyanide poisoning. It is also used as an antidote in case of poisoning from iodine preparations. It is an effective antifungal and useful in skin infections such as dermatophytosis. It is used as antichlor in bleaching and as a fixer for negatives and prints in photography. Then storage. Its alkaline solution are stable, so if it is to be stored, a sufficient amount of sodium carbonate or borax is added to make it stable. Sodium thiosulfate should be stored in airtight container. Then incompatibility. It is incompatible with salt of heavy metal, oxidizing agent and acid. The next compound, sodium nitrite and inert atmosphere as a nitrogen. In that first one we have to see about sodium nitrite. The molecular weight of sodium nitrite is 69 and molecular formula is NaNO2. Then characteristics. Sodium nitrite contain not less than 97% of NaNO2. It is white to yellowish white granular powder to white opaque fused masses or sticks with saline taste. It is odorless and deliquescent in air. It is freely soluble in water and sparingly soluble in alcohol. Its aqueous solution is alkaline. Sodium nitrite is decomposed by dilute acid with the evaluation of pale brown fumes due to instability of the liberated nitrous acid. The reaction is as twice NaNO2 plus H2SO4, which gives Na2SO4 plus twice HNO2. And then thrice HNO2, which ionizes as a H2O plus twice NO plus HNO3. The nitric oxide is oxidized to give NO2, where twice NO plus O2, which oxidized as a twice NO2. Then next one, uses. Sodium nitrite is not used specifically as an antioxidant, however, used as a reducing agent when combined with sodium carbonate. This combination is available as anti-rust tablet. It is used as an antidote for cyanide poisoning because of its ability to induce methemoglobin formation on injection. Sodium nitrite has vasodilator effect. Sodium nitrite is added to aqueous disinfectant solution in 0.1 to 0.4% concentration to prevent rusting of surgical instruments. It is also used as a preservative in foods. Then storage. It is stored in airtight container. Then incompatibility. Sodium nitrite is incompatible with oxidizing agent phenazone, acetanilide, caffeine, citrate and morphine. The next one, nitrogen. Molecular formula is N2 and molecular weight is 28. Then we have to study about characteristics. It is colorless, odorless, tasteless gas. It is non-flammable. This gas is not poisonous but does not support animal life or combustion. It is slightly soluble in water. It is slightly lighter than air. Then uses. Nitrogen is an inert gas and hence it can be used to protect chemicals, pharmaceuticals including vitamins, oils from air oxidation by displacing the air in containers. It is also used to retard oxidation in the quantitative test for carbon monoxide. Then storage. Store under compression in metal cylinders. The cylinders of nitrogen are painted grey with black neck and shoulder. Thank you.